A child can learn everything that their math teacher is showing them in class, and yet when they get home, they seem to forget everything, or at the very least, they don't know how to solve anything that they had just learned hours ago. This sound familiar? Hi, my name is Paul Garrison, and I was a public school teacher for 17 years. And in that time, I had taught math to elementary school students, middle school students, and high school students. And in this video, I want to go over why it is that a child can understand the lesson perfectly and even do the lesson fairly well when it comes to math, but then when they get home, they seem to struggle. And we're going to go over what is the purpose of learning math and its various topics, and how each of those topics can be covered and learned to various levels of depth, and how it is that when they get that lesson in the classroom, how it's designed to make it much easier for them, how to improve their math fluency, how even just one step can throw off any good math student, and how math, it should be thought of as more like an instrument. And by the end of this video, hopefully, we'll have given you a clear idea of why your child may be struggling with math at home, and hopefully given you some tools to help them become a little bit more of a math magician. You need to learn this so that one day you won't need a calculator to solve a problem. Now, does this sound familiar? It was a line that I was given growing up when I had to learn math. And the real question is that really the reason that we learn math? Now, I personally would argue the reason we learn math is something else. It is basically that math teaches us and students how to think logically, how to think in a clear progression, how to think and solve something step by step by step. And that is the greatest benefit that math really gives us. That's the purpose of why we learn it. Now, I know when I heard the excuse, or I don't want to use the word excuse, but when I heard the reason of why I had to learn all this math at a young age, and you know, you're not going to have a calculator all the time to help you, so that's why you have to learn it now. I mean, nowadays that's simply not true. Between everyone having a calculator on their cell phone and the numerous apps to help you solve problems, and then also with AI, the truth is all of us have within our reach this ability to have a math problem solved for us. So again, that's not the reason why we learn math. Math teaches us how to think logically. So the more math a child can do, we're teaching them to think in a logical manner. And I have found this had worked for me when I was teaching the classroom. When I told my students that this is the reason why we're doing this much math. This is the reason why you're going to be learning math. Here's the reason why we're practicing it so much. It's the reason why I wouldn't give them a calculator either, and I wouldn't let them use their timetable, because I said, because we're trying to teach you how to think and think clearly. I personally found there was more buy-in from the students once they understood that. And so truthfully, yes, a calculator can give you the answer, but it cannot replace having the ability to think through a problem. The difficult thing about math is that one weak skill rarely ever stays as one weak skill. And the reason why is because math builds upon itself. Each skill leads into another. It's like a progression, and all new skills depend on a child being proficient at a previous skill. I used to teach sixth grade, and I always knew going into the year there were a few skills that if they didn't have it when entering my classroom, it was going to make the rest of the year simply more difficult. The biggest culprit, and again, this is just from my experience teaching from my classroom, it was if they didn't know their multiplication table. Now, I've met many other educators who would agree with this, and the thing is, I could tell the students from almost from day one, like, hey, if you're struggling with multiplication, we're going to practice it. But I want to give you an idea of all the skills that I have to teach you this year where you will need to use multiplication, such as GCF, LCM, ratios, percentages, working with expressions and then equations, finding area, finding volume, etc., etc. I mean, there were numerous ones, long division. And so if a child is weak at one skill in math, it will affect another skill later on. And so, as parents, one of the things that's probably the most beneficial thing you can do is just be involved really early on with your child's um, learning math, especially the fundamentals, addition, subtraction, multiplication, division, because those will keep repeating and reappearing in later math. And just even though they may, let's say, finish an assignment or maybe do well on a quiz, just to really ensure that they really have certain skills down and really think like there's some things that are non-negotiable. They should really have them down. Multiplication facts, for example. And just help them master the basics in math because as I've kind of found, an ounce of prevention is worth a pound of cure in math. But they said they could do it in class. And yeah, that's by design. So I'm sure for many parents who they've talked with their kids and their kids like, well, I could do it in class, but then when they get home, they suddenly can't do that anymore. I want to let you in on kind of how a lesson is designed by any teacher. This is for math teachers, but really any teacher in general. Usually, if you're going through like a math lesson, there is an explanation of the skill being learned, then a demonstration of how to do that. Then there's imitation by the students, which means they usually work through problems with the teacher. And then there's the repetition part where they start to practice many problems on their own. And all of those are involved in a lesson, but especially the first three, the explanation, demonstration, and the imitation part. And I mean, I can't speak for every single teacher in existence, but basically, this is really beneficial in teaching students a new concept. But the thing is, and this is by design, that the student's hand is being held a lot during that process. There's a very specific explanation being given. There's no, usually not a lot of problems where there's exceptions to the rules being given. And basically, all through that time, every example, every explanation is very carefully given to the students to have them get a lot of success early on. And that by the way is a good thing because we want them to feel as comfortable as possible with a new topic. And so for parents, just understand if you're going, man, that's me. Like they're telling me they get it at school and then they get home and they almost forget. It's not necessarily the worst thing. It's the students should have success with a new topic in class and in school, and ultimately it just means that they really haven't practiced it or mastered it enough. But I think what would be worse if they tell you I was in class and I didn't understand anything. That's a bit scarier. So just parents to understand if you're getting they understood it at school, they're not able to do it at home. It's not the worst thing. It's not that bad. And listen, the lesson is designed to help them get it, but it's ultimately the amount of practice after that that allows them to keep it and own it. So whenever I've heard someone say, "My child is good at math," in my head I always think, well, which part and how well? And the reason why I think of that is something that may be helpful to parents or other teachers is to think of math has both breadth and depth. Breadth meaning there's numerous topics and skills that a student has to learn, but then depth meaning there's a level of mastery that they can achieve for each of those topics and skills. So let's just look at the idea of just the amount of topics. Um, this could be, let's say, even just long division. So within long division, there's like simple one digit division. So, for example, 8 divided by 2. But then let's say we get more complex. So it's a two-digit number divided by a one-digit divisor. And then there's division, but now there's remainders. And then there's the beginnings of long division. And maybe it's long division where the dividend is two digits and the divisor is one digit, but then we can start to make that a three-digit dividend and keep it as a one-digit divisor, or perhaps you can make it now a two-digit divisor. And perhaps now we don't deal with remainders anymore. Now we start adding decimals, and then we start adding zeros as placeholders, and so on and so forth. And then maybe now the divisor is a decimal itself. And so now what do we do with that? So even within, let's just say, long division or division in general, there's numerous topics to cover. But now let's get to the depth of it. So what I mean by depth is, okay, so how well can you apply that? So for example, can you multiply, or I guess we're talking division. Well, because division is really multiplication and division and subtraction all involved. So for example, can you do most of it fairly quickly in your calculation? Let's say within under 15 seconds or so. Can you do it mentally in your head? Can you do it without any paper and pencil? Can you do it now presented as a word problem? And not only presented as a word problem, but different types of word problems. And then can you, let's say, there's a number missing in the process. Can you explain what number is missing and why? And then can you explain how to solve all that to another person and explain why it works? So that's what we mean by the depth of understanding of a topic. Now, as parents, just think, when you think of a child maybe struggling with math, is that they don't know the topic or they don't have a certain level of mastery behind it. In my experience, I've always kind of found that for most students, it tends to be they don't understand certain topics, and there's numerous reasons for that. Maybe they were absent that day for the lesson, but then from there, even if they do understand the topic, is what's their level of mastery behind it? And I think it's a good framework to think of how well does a child know a skill in math. And it's like the topics is what they know, but the depth of it is how well they can use it. Math will always add more steps and more complexity, but fluency makes it easier to navigate. So what exactly do I mean by math fluency? It just comes down to how does the student do with, let's say, just simple math, but can they do it to a point of automaticity? Can they do it to the point where it doesn't take much cognitive energy to actually calculate it? Can they do things like 2 plus 3 in their head quickly and rapidly, no assistance from paper and pencil, and hopefully not a calculator? So that's what I mean by fluency. And if a student is really struggling to do math independently, their math fluency is a very good place to start looking. Now, practicing to a point of automaticity. Take, for example, like their multiplication facts. Can they do those without the assistance of a times table? Can they do it to the point where it's almost all mental math and they can do it fairly rapidly? And also, especially early on for children, when they're learning the very beginnings of math and like the real fundamentals, personally, I would not give them a calculator. It really robs them of the opportunity to really think through and develop that automaticity at that point. But if you're a parent, one way to really develop their automaticity, to develop their fluency in math, is just to practice with them a little bit each day, see if they're solving it a little bit faster, see if they can do it to the point where I'm actually a real big fan of mental math. No paper, no pencil, just do it in your head. That has some limits. I would always start with basic computation, but start with addition, subtraction, multiplication, and division, especially for multiplication and division. Like the real simple multiplication division problems at first. Don't give them like a 4-digit number divided by a 3-digit number or anything like that. And then again, just that constant practice with that really helps develop their fluency. And what fluency does, it turns basic math into something that students have to think about into something that they can think with. Even some good math students will still run away from word problems. Why is that? Well, just quite simply, word problems are very demanding of students. And so what? Word problems are very important to helping students become logical thinkers. Now, why is it that word problems are so demanding? It's because most problems are given to a student and they'll tell them, divide these numbers or find the percentage here. And word problems, they remove that one step where it's not just the calculation anymore. Now the students have to figure out what exactly they're calculating and in what fashion do they have to calculate. And because of those extra steps, it is more demanding. And also, when we say word problems, there's three types, at least I say there's three types. There's a basic word problem, which is it's a math problem that you would do as far as addition or subtraction or percentage or ratio, but they just put words over it. So it's the same calculation you would normally do, but it's written in words. But then there's multi-step word problems where you have to do different types of calculation and multiple steps of them throughout the problem. So maybe the first step is addition or subtraction, but the next step might be percentages. And those are more complicated. The last one I describe as being a word problem are the ones that involve strategy specific word problems. Basically, there is a very specific strategy that you have to use. It might not even involve any operations. It might just be you have to make a chart and use a process of elimination, or that you might have to solve the problem by working backwards. Especially if you can think of a problem where they say these 5 kids are in line. This one kid is in front of the other one, but this one is 2 spots behind this one. Tell us the order of the line from front to back. There is no multiplication that'll help you solve that. But what is involved, and it goes back to the point of math, it does involve logical thinking. It involves reasoning. And so those are really good problems there. So if you're a parent, just know that if your child is struggling with word problems, they are not alone. Almost every child struggles with word problems. And a good way to maybe help them with it is when they do have those word problems, think, is it one where it's just a basic math problem but written in words? Is it one where there's multiple steps and multiple calculations involved? Or is it one where it involves very specific strategies that they have to use? And the thing about word problems is this, and why it's so important to math. Knowing how to calculate is important, but knowing what to calculate, that is actual problem solving. A student can get the right answer in math and still not fully understand why it works. Now, we would call this reasoning, and reasoning just means it's the ability to go beyond just performing the steps or just calculating. It's really asking the question, does my answer make sense? Or can I justify my answer to someone else? Can I explain all the steps I took to get to this answer? And maybe even if someone else did something completely different, can I look at it and go, that's correct or that's not correct, and here's why? Reasoning is a really important part of a student developing their math sense and developing their ability to do math at a more proficient level. Now, there's many examples how you can do this, but one activity I used to have my students do, there was this lady named Marcy Cook, and she had these things called number tiles. And she'd have all these packets, and I'll just give one example. Let's say they're doing long division, and there would be a long division problem on this one card. It takes the whole page, and it's technically finished and done, but there's certain numbers or digits missing throughout the entire problem from all over. It could be in the divisor, it could be in the quotient, it could be in the dividend, or even the steps in between. And you had these number tiles 0 through 9. And you had to put them onto the card in the correct spot so that it shows how the division should work. And so the whole time students were doing that, they had to constantly think, this number goes here because it follows this part of the steps or this part of the process. It's involved in the multiplication, or it's involved in the division, it's involved in the remainder, or it's involved here where we're subtracting. So it's not only that they had to know how to do the calculation correctly, they had to basically explain it and put these numbers in the correct spots. And I always thought that was a really good way for students to develop their reasoning. Now, if you're a parent, instead of asking your child, why is this the answer? Or what is the correct answer, I should say, ask them, well, how do you know? Why does your answer make sense? Or basically, you could say, well, here's my answer. Why is mine right or why is mine incorrect? To basically take that one step further where they have to really explain or justify the answer or the reason behind it or the process behind it. And when students have an answer, that tells you what they got. But if they can reason with you, it really shows that they understand. The better a child is at taking notes for math, the more the lesson will stick with them. Now, looking at a bunch of examples is nice, but actually writing down the examples is much, much better. Even if they have like a packet where it does the examples for them, I used to always recommend to my students that they should still write it down in a notebook. And the reason why is this: if they're actively writing down the steps and writing down these examples, they're much more involved in the process of the actual problem. And they engage much more with the process. And so I actually made my students write down all of the notes that I would put down on the board. I don't know if that makes me great or evil in someone's eyes, but that's what I had my students do. And I can only speak on my behalf, but it worked really well for me and my students, basically. And here's the thing, eventually, all of math gets reviewed. So for the students I had that took really good notes, they were able to reference those notes when we did eventually come to a topic that had to be reviewed, or eventually to a topic that they maybe forgot that we had done from months earlier. So good notes, it really helps them out in many different ways. So now as a parent, you don't really have much control about whether or not your child's teacher will make them do notes or make them do notes a certain way. But at least on your end, you can emphasize the importance of good note taking and make sure they know that it really does help them out. It's something they can constantly reference. And that also, when they take really good math notes, that's what allows for the lesson to go from the classroom back to home. I once had a student whose math notes were so good, she kept using them once she got to middle school. So when I had this one student, I had her for sixth grade, and she had improved a lot in math across that whole year. Not only her ability to do the math, but also she improved the way and the manner in which she took her math notes. Now, because she put so much emphasis into taking very good notes, she was basically consistently able to go back and look at what her notes said, the examples we used, and the problems she had solved whenever she needed to reference something that she just wasn't quite sure, like, hey, am I doing this correctly? Is that the way I had learned it and everything? And apparently it was so useful that once she had finished my class and moved on into middle school, she took her math notes with her, and she'd come back and visit, and she told me that she kept using it all the way through the next school year because she had taken such good notes, or I guess our class had emphasized the importance of just good note taking, that she used it. And she said it was very helpful for the entire first year of middle school for her. So it goes to show that taking really good math notes, it's really helpful. So as a parent, again, maybe you don't have control of what the teacher emphasizes or mandates as far as note taking, but you can emphasize to your child how important and useful good notes are in math. And if you want to share the story of my student, feel free to do so, because it's something that they can use even going into the future. And really, good notes is the gift that keeps on giving. It only takes one confusing step to throw a child completely off a math problem. So, what I mean by this is as students learn more and more math, it's going to become more complex. There's going to be more steps involved. And if it's just that one step that's throwing them off, it looks like the entire problem is confusing them, but it might just be down to one step. I can think of a few examples of this. One would be when students start learning order of operations. And for those who may not know, it's usually, well, at least when I was growing up, I had it taught to me as PEMDAS. So parentheses, exponents, multiplication, division, addition, subtraction, and all that. I know there's other ways to phrase it. That's how I learned it. That's how I taught my students. And the importance of the order of that, because if they do anything slightly out of order, they'll see that the answer they get is drastically different from other students' answers. And so it only took one step and it was completely off, whether that be doing something in the wrong order or just doing a bad calculation within that one step. Another way I can think of describing this is when they first begin learning about equations in algebra. So once they start learning how to solve equations, especially multi-step equations, it's tough for them because they have to think, well, what would be the next step that I would take? Should I distribute in the very beginnings, or should I find a way to get rid of the fraction in the very beginning, or should I move all the variables to one side if we have variables on both sides of the equation, or should I add and subtract or before I do any multiplication and division? It just takes one of those steps to throw them off. And so for parents, don't assume they're struggling with an entire problem or an entire topic. It could just literally be one step that's throwing them off. And once they get an explanation for how to figure that out, they make much, much better progress. So you don't have to misunderstand the whole problem to get stuck. Sometimes it only takes one step. Even Bruce Lee can teach us a lot about what it takes to be successful at math. So the quote I'm going to refer to is the one where he says, and I'm paraphrasing, but he essentially says, "I fear not the man that has practiced 10,000 kicks once. I fear the man that has practiced one kick 10,000 times." And there is a truth to that in math. Math takes a lot of practice, a lot of practice. And I just feel like the sooner that students, parents, and teachers accept that, then there's more success. And maybe I'm wrong, but I guess I felt when I was teaching in the classroom that I didn't hear enough teachers really emphasize how much practice was involved for a student to get better at math. And even just missing one day or so or 2 days a week where maybe an assembly or something came up, I thought it was a big deal. I thought it always pushed students further and further behind. Now, to get to that point of not struggling with math, again, if children are coming home, they're saying, I could do the lesson in class, but not at home. It's just a matter of they haven't practiced it enough. They don't have enough repetition in that skill. They do not have it to a point of mastery. And it takes a lot for them to build the proficiency, to build that confidence in the skill, and to truly, truly understand it. It takes a lot of time and repetition to master it. So parents, it's important to just accept math will take a lot of practice, a lot of repetition. The homework for math has to be treated very seriously because it's supposed to be designed practice for them. And there are some skills that they're going to need to master and memorize. Multiplication facts, for example. And that if they don't have it, they will continue to struggle in many, many things. And so at home, I know sometimes we can think, well, it's the school's responsibility. And there is truth to that. I can accept that as someone who taught. But man, the more, if parents could go, but we're going to make sure these things are taken care of, it really does go a long way just to be willing to put that extra work in with them. Basically, the shortcut to getting better at math is realizing there is no shortcut to getting better at math. So I used to show the movie Miracle to my students every year, and there's a scene where the coach says one word many times, and I told my students to get used to hearing it again. Now, I used to say the word again a lot with my students whenever I would get a new example ready for them, or we want to start to learn a topic so well that we just did like numerous examples, numerous practice problems. The reason why, well, there's many reasons why, but one example is that many types of math topics have what I call specific examples that students, they'll eventually see them after doing many repetitions of a particular skill. And there's no way for them to eventually see that very specific example unless they have the practice and the volume of practice necessary. Here's what I mean by specific examples. Let's take a look at mean, median, and mode. Now, technically, to find the median, you have to put the numbers in order from least to greatest, and it's the number in the middle that's called the median. Now, that's nice if there's only one number in the middle, but what if there's two numbers in the middle? Well, okay, then you add them up, divide by 2. Now, that doesn't sound that complicated, but it takes a bit of repetition before you get to that example. And then even once there's that number in the middle, let's say from there, then you're trying to figure out first and third quartiles. So how do you figure out first and third quartiles? Well, first you find the median of the data set, and then you take the first half and find the median of the first half, and then you take the second half of the data set, and then you find the median of the second half. But it depends, because what if there's only one number in the middle for the data set? Or what if there's two numbers in the middle for the data set? And then likewise, when you're finding the first and third quartile, what if there's only one number? What if there's two numbers? And so there's always these kind of what if situations. And also for multi-step equations, like I said from earlier, so are we distributing first, or are we getting rid of a fraction first? Should we move all the variables to one side? Should we combine like terms first? Should we do addition, subtraction, multiplication, or division in this particular one? You have to do enough repetition before you start to see these problems and see these unique specific examples and then know what to do with them. Hence, the word I constantly used with them was again, 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 practicing so much that eventually when we saw these specific examples, we weren't caught off guard by them. So now as a parent, please feel free to give your child more and more practice and more examples. And by all means, feel free to use the word again with them. And practice does more than just repeat a skill. It prepares students for a version of the problem that they have not seen yet. Math is like a musical instrument. It requires consistent practice. So this was the example I always gave my students. I would say math and music have a lot of similarities. They're both taught in an explanation, demonstration, imitation, repetition type of fashion, and they both only improve through practice. So if you think about a student who's learning an instrument, now look, at first, they probably have a lot of things that help them out. They have the sheet music in front of them. They probably have a teacher who's counting along and helping them through a piece of music. And maybe at first, they don't necessarily start just with a metronome, but then eventually they start to add a metronome in to help them with the timing of the piece. And then they have the notes right in front of them in the sheet music, and that all is very beneficial. But then you have to practice it more and more till eventually the metronome starts to disappear. The sheet music and the notes starts to disappear from in front of you, and it has to kind of be all up here, kind of like mentally or through automaticity. And math is a lot like that. The more and more we can rely less on the teacher to be able to answer every last question we have, or to be able to only rely upon the notes that we take, or to basically not have all this assistance, but to the point where they can get any problem put in front of them and they can trust the process of how to solve it. There are a lot of similarities between the two. So if you're a parent, just if you're a parent and you're trying to help your child become more independent with math, where you're not having those moments where they're saying, I could do it at school and I can't do it now. Again, practice and repetition. It's like an instrument. And that if they're not able to do it at home, it really just means they have not practiced enough. They don't have enough repetition with that skill. They have not mastered it yet. And it's like if you took a musician and you just said to them, "Hey, you've seen this piece of music once. Why don't you have it down yet?" It's kind of saying the same thing to a child of like, "Well, you got the lesson on this. Why don't you have it down yet?" It takes a lot of practice. And the lesson teaches the skill, but it's the practice that makes the skill available once that lesson is gone. A student can feel miles behind in math, but in reality, they're only one or two skills behind. Now, I had a math teacher many years who explained this concept to me where he was saying that for most students, that they're only one or two skills behind the rest of the class. And once they get enough practice with that, they actually get caught up. But from the child's perspective, it might feel as if the other students, it's like a car that's just pulling away from you, but they're only going like 65 miles per hour while the child is going 60 miles per hour. There's really not a huge difference. Now, I want to point out, yes, of course, there are some children who are very far behind in math. I'm not saying that that's not the case, but for most, they're really not that far behind. So if you're a parent here, basically just know that it's not that they're bad or incapable at math. They really might just be behind on one or two particular skills, and then they'll feel caught up. And so it's an important question to ask yourself. So where exactly is it that they're struggling or slowing down? When they do come home and say, like, I can't do this at home, I could do it at school, instead of throwing your hands up in frustrations, be like, okay, well, what's the particular step where you're getting thrown off? So just understand, they may not be miles behind. They might only be one or two skills behind, but on a road that never stops moving. A child can genuinely understand the math lesson in class, and yet they still come home and struggle. Remember, in class, they have constant explanations and they have examples, they have support from the teacher, and all that support is by design. It is there to help them have success. But when they do come home and if they're struggling to do it again or they can't do it on their own at that point, it just means they need the repetition. They need the practice. They haven't mastered it yet. They haven't mastered it without all of that support in place. But also, truthfully, they might not even be that far behind. It might be only one or two skills, one or two steps that's throwing them off. So don't think it's the entire subject or it's the entire lesson. They're probably not that far behind. Thanks for watching and thanks for listening. And until next time, take care.